We will start with the first problem. A smooth 2 kilogram collar C fits loosely on the vertical shaft. If the spring is unstretched when the collar is in position A, determine the speed at which the collar is moving when y is equal to 1 meter if A is released with an upward velocity of 2 meters per second. So in this problem, we have a collar that is attached to a spring, and it's moving from an initial position to another one. As I told you, always when you have motion from one position to the other, and they are giving you the displacement distance, or they are asking to find it, think about work and energy. Okay, so we start by defining the states. This is the initial state. At the initial state, the collar is at position A, and at the final state, it's at position C. Now, to know if we want to apply work and energy or conservation of mechanical energy, we can just draw the free body diagram of the collar to see if our forces are conservative or not. So the first step will be to draw the free body diagram at a certain arbitrary position. What are the forces acting on this collar? What are the forces that I should represent here? Who will tell me? What are the forces acting on this object?
Object
Weight.
Weight, very good.
Amazing.
Tension.
Tension of the spring. Do I have anything else?
Friction كمان.
Normal.
هلا, no friction. Yes, very good, normal. No friction because they said it's smooth. So we have here smooth surfaces, no rough surfaces to have friction. We have a normal reaction. Yes. Can you tell me, is the normal reaction from this side or this one? What do you think? Here, the collar can do a force on this part, okay? Or can do a force on the other part. How to know what to do? Look, انتو عادة الcollar مين عم بيشد فيه الspring صح؟ The spring is tending to develop on the collar a force in this direction. So what will happen if you do the analysis along x direction? Do you have any motion of your collar in x?
No, that means there needs to be a force to oppose the spring. So
Yes, exactly. Since you don't have any motion in x, sum of forces along x is 0. And since the spring force is always to the right, then the normal reaction should be to the left. This means that the collar, okay, will do an action on this surface. Yani it will do a force on it towards the collar will tend to do a force on the surface here towards the right, and by action reaction, this surface here will oppose this by a force to the left. Yani the collar is supported by this part of your surface, not this one. لو the spring force is opposite, ساعتها كان الكولر بيشد على هيدي البارت وبتطلع الفورس من السيرفس عليه in the opposite direction. So this is how I can determine how my normal is. But here, I don't need to find it, to calculate it. Why? Because when I do the principle of work and energy, this normal is always perpendicular to the path of motion. The path of motion is vertical. So the work of N is equal to 0 since perpendicular to motion. So no need to find what is the value of N. Okay? Anyway, your normal is varying because the spring force will vary with position. So the normal is not a constant. At each position, you have a certain value for your normal. Okay? So the only forces doing work are the weight and the spring. And because these two forces are conservative, you can apply conservation of mechanical energy in this case. Okay, or work and energy, both are right. Now, is anyone asking a question? Okay.
هنا بنحكي عن الأوبجكت A. الأوبجكت A ما هيك؟
Yes, the object هو الcolor. It's moving from position A to position C. يعني A إذا بدك هو اسم البوزيشن. The color was initially here at this position سميناها position A, and it will move downward a distance of 1 meter to occupy a final position at C. Okay, so A is this the upward position, C is the downward position, and the object which is moving is the color. This is the color. Okay.
Okay.
Now they told us that this color, okay, is moving towards C, but it is released with an upward velocity of 2 meters per second. So because I'm releasing it with an upward velocity, my color will first move up and then will go down to C. And they are asking me in the first step to determine when it will reach C, what will be its velocity. Okay, so the question is to find the velocity at C. It's unknown. I know that it's released from A with an upward velocity of 2 meters per second. So I know at A everything. I know the velocity, VA equals to 2 meters per second. I also know that my spring is unstretched when it is at A. So delta L when at position A of my spring is 0. So now, if I want to apply the conservation of mechanical energy between A and C, I can write that the kinetic energy at A plus the potential energy. Here I have two types of potential energy. I have the gravitational potential energy at A, and I also have the elastic potential energy at A. Should be equal to the kinetic energy at C plus the gravitational potential energy at C plus the elastic potential energy at point C. Now, let us start to replace in this equation. First, VA is known, so the kinetic energy at A is half times the mass of my color, which is 2 kilograms, it's given. So it's half times 2 times the velocity at A square, which is 2 square. Plus, now, whenever I have a gravitational potential energy, I should determine a reference line, okay? You can take the reference wherever you want. As we have seen together, the choice of the reference level will not affect delta GPE. It will just affect the value of GPE, but not the difference, okay? And what I care for is the difference between GPE at A and GPE at C. So if I take my reference at A, this is a good choice because in this case, the gravitational potential energy at A will be equal to 0. Now, what about the elastic potential energy at A? What is the value of this energy?
0.
0, because the formula for EPE is half K delta L squared. And since delta L at A is 0 because my spring is unstretched, so also no elastic potential energy at A. So I am done with the first side. So plus 0 equals 2. For the other side, I don't know the velocity at C. It's my only unknown. So I express the kinetic energy function of VC. It's half times the mass of the color, which is 2, times the velocity at C to be calculated square. Now, for the gravitational potential energy at point C, okay, you have C is below point A. It's at a distance of 1 meter below A. So it's a negative potential. So I will put minus the mass of the color, which is 2, times G, which is 10, times H, which is 1. Okay. And finally, to calculate the elastic potential energy at point C, what do I need to find? So in general, the formula is half K delta L at point C square. So in order to finish my equation, I need to get what is delta LC. So in this case, I will use geometry to find what is the stretching of the spring at point C. If you look at your figure, you know that to calculate delta LC, I need to find the total length of the spring at position C, okay, minus L0, which is the unstretched length. The unstretched length is known because at the initial state, I will just erase so that it will become clearer. At the initial state, they told me the spring is unstretched. This means that this distance represents L0, which is 0.75 meters. Now, when my color is at C, this is LC. LC is the length of my spring at this position. And since I know that the displacement of the color between A and C is 1 meter, and I know that L0 is 0.75, and this triangle is a right triangle, I can use Pythagorean theorem to find the hypotenuse. So I can just write that LC is equal to radical of 1 square plus 0.75 square. And once I calculate LC, I should not forget to subtract L0 from it to get delta L of C. So delta L of C will be equal to LC minus L0. So I should do minus 0.75. In this way, I calculate the value of delta LC and I replace in my formula. So replacing in the formula, the only unknown will be VC. I can get the velocity of the color when reaching point C. Any question on this part? Okay. Now, they are asking me what would happen if instead of giving initially to A an upward velocity of 2 meters per second, what if I give it a downward velocity of 2 meters per second? Will this affect the velocity at point C? Who can tell me?
I'm sorry, can you repeat if you did what?
If we, in this problem, they told us that the color was initially given a velocity of 2 meters per second upward. And they told us calculate what will be the velocity when it will reach point C. If they changed the question and instead of telling us we gave it an upward velocity of 2, if now we are giving it a downward velocity, an initial downward velocity of 2 meters per second, what will change? Will the velocity
تزيد
الاي بي اي بده يتغير بده يزيد.
الاي بي اي تبع مين بده يتغير؟ على السي؟
تبع السبرينج على سي.
طيب وقت يوصل على السي، وقت يوصل الكولر على السي، هتتغير اللينكس بي سي؟
لا
نو، الاي بي اي ما بيتغير. الجي بي اي بيتغير؟
no.
No. At A بيتغير شيء. نحن بالكالكوليشن أول شيء نحن بنفس البوزيشن، يعني الجرافيتيشنال انرجي والبوتنشال انرجي ما بيتغيروا. هلا الكاينيتيك انرجي how do I calculate it? It's half mv square. Do I care if v is positive or negative when I do square?
No.
No. طب physically okay فهمنا انه equation will tell us that nothing will change, but physically why if I give it an upward velocity or downward velocity but of the same magnitude nothing will change? Do you remember what was the definition of conservative forces?
Yeah, they don't like the path مخصو
Exactly. For conservative forces, if I go from the same point back, يعني I go from one point and from an initial and final point that are the same, I don't care for the path of motion. As long as I am going from the same initial state to the same final state. Here, at the initial state, I still have the same kinetic energy, and I still have same potential and gravitational. So if I just give an upward velocity, what will change is my path. So I will move a little bit upward until my velocity will be equal to 0. Because in this case, as I move up, I will gain potential energy and elastic energy, and I will lose from my kinetic energy. Once my kinetic energy becomes 0, I will move back again. And when I pass by A another time, I will pass by A with the same velocity, but instead of passing by it with a velocity that is up, I will pass by A with a downward velocity of 2 meters per second. So why? Because when I have conservative forces, I don't have loss of energy. So when I come back to the same position, I will come back to it with the same amount of energy, but the only difference is that instead of having my velocity up, when I pass by again by A, my velocity will be down, but same magnitude. So I will go again to the same state of the previous question, and I will continue my motion until reaching C. This is because the forces applied on my collar are all conservative. I will not lose any of my energy during the pass. And the characteristic of a conservative force is that its work is independent of the path of motion. Just it depends on the initial and final state. Okay. Now, who can give me a small modification that will lead to energy loss? And then it will not be the same if I move up or down.
If it were a rough surface that you were going up and down.
Very good. If it was a rough surface, then as I move, I will lose energy due to friction effect. And then if I give an upward velocity of 2 meters per second, I will lose a part of my energy as I am moving. So when I go back to A, in this case, if the surface is rough, I will not go back to A with a 2 meters per second. I will reach A with a lower velocity, smaller than 2. And then it will be better for me to move downward from the beginning, because when I move up and go down to A, I lost a part of my energy. So whenever we have a non-conservative force, then the path of motion, of course, will have an effect on my energy. However, if all forces are conservative, then whatever is my path of motion, if I start with the same initial state, I will get the same final state. Okay. Any question on this? So this was the first problem. Another problem.
بس سؤال.
Yes.
نحن كيف عرفنا إنه conservative الforces؟
What are the forces doing work in this problem?
الفريكشن ما برناها.
ما في friction. Normal ما عندها work. في الweight والspring. الweight والspring هن ال 2 conservative forces اللي تعلمناهم in this course.
Okay.
Okay. And we
Okay,
have
good.
defined a gravitational potential, and we have defined an elastic potential.
Okay, great. Merci.
Welcome. Another problem. A small block slides. Do you want me to zoom in, or it's fine?
No, it's okay. It's okay.
Okay. A small block slides at a speed of 2.5 meters per second on a horizontal surface at a height of 1 meter above the ground. Determine the angle at which the block will leave the cylindrical surface BCD and the distance x at which it will hit the ground. Neglect friction and air resistance. This is a very important problem that combines several chapters. Okay, so first, what we have a block. We know its initial velocity, v, it's initially moving at 2 meters per second. Now, what will happen is that my block will move on a circular curve from B to C, but at a certain point, it will leave the surface. Do you remember what is the condition to leave a surface?
unequal to 0.
Very good, n equal to 0. So when the block will leave the surface, there is no more contact between the surface and the block, and the normal reaction will become equal to 0. So they are asking me first, at what angle theta, what is theta for which the block will leave? So what I know for theta where my block will leave the surface, normal reaction becomes 0. So if I want to represent forces on C at this point, I will have the weight only because there is no normal acting on it. Now, they should tell me if the surface is smooth or not. They told me neglect friction and air resistance, so no friction forces. So at this point, the only force acting on my block will be the weight. Okay. Now, I have several unknowns in this problem. I don't know the position at which n becomes 0. And I don't know what will be the velocity v, also v of my block at this position. Can you tell me what will be your strategy to solve for theta? What equations you can think about?
UN?
Very good. First, since you have circular motion, always think about putting the UNUT frame and projecting your forces. So here, I have my block is moving downward. So UT, if I want to represent UT, I will change the color. UT is tangent to the path downward. So this is my UT. UN is always directed towards the center of rotation. So this is my UN. And here, no need for UB. You can put it, but all forces are in plane UNUT. So UB will not be helpful. So UB here is perpendicular to the screen, okay? But I don't need it because I don't have any force along UB. So already sum of forces along B is 0. This equation will not give me anything. So I can write equations along UN and UT. Let us start with UN, okay? If I want to project forces along UN, the only force is the weight. And the projection of the weight on UN is positive. So when I write sum of forces along UN equals to MAN, I have to project the weight along UN. From my figure, this angle between the vertical and the radius of the circle is equal to theta. Okay, and this theta is equal to this angle because they are alternating angles. So when I project the weight on UN, I have plus mg times cosine of theta equals to mv square over the radius of rotation, which is r. So this is equation number 1. In this equation, what are my unknowns? Theta is unknown and velocity is unknown. So I have 2 unknowns. I need an additional equation to close my system. Which equation do you think can relate theta to V? What can you think about?
بس بهذا كيس الار شو؟
conservation of mechanical energy between B and C.
Very good, very good. R here radius of the circle, okay? And R represents the radius of curvature. And here, since it's a circle, the radius of curvature is the radius of the circle. So it's R. It's this distance, it's given. Okay, the radius of the circle is given. It's equal to the height h. It's equal to 1 meter. So R is known, it's 1. The mass is known. Look, even they don't give you the mass because you don't need it, okay? Because look, you can simplify M from both sides. This is why they didn't give you the mass of the block. So please, sometimes, no need to say I cannot do the problem, I don't have the mass, because a lot of times the mass will simplify. So write your equations and you will see that you will not need it. Now, as Karine said, we have conservation of mechanical energy between the initial position at B and C, because the only force doing work is the weight, since the normal between B and C is always perpendicular to motion. Okay, so you have, if you take any arbitrary position between B and C, you have, let me clear it here. So whenever you want to determine the forces acting on your system, you take any arbitrary position between B and C. Between B and C, the forces acting will be the normal, which is perpendicular always to motion, and the weight. So N, even if N is not 0, so at any point between B and C, N will not do any work since it's always perpendicular to motion. So only the weight will do a work. This is why, or you can do the principle of work and energy, or you can apply conservation of mechanical energy. It's up to you. Since we applied in the previous problem conservation, let us remember work and energy. So if we want to apply now work and energy between B and C, we can write that the kinetic energy at point B plus the work of the weight, we only have the weight doing work between B and C, is equal to the kinetic energy at point C. Now, yeah. It's Hassan.
No.
I don't
Yeah,
hear.
it's me.
I don't hear you well. Can you repeat?
Yeah, I asked, where did you get these questions from?
It's questions that I suggested for the midterm.
Oh, okay. Forgot from like a PDF or something. Thank you.
Okay.
دكتور
Yeah.
بس بدي أتأكد من شغلة إنه هيدا ماك 230 صح؟
نعم.
بس
Yes.
بدي
Yeah.
أتأكد. Okay, thank you.
Yes, it's dynamics. It's Mach 230. Yes. Okay. So now, when I write my equation, I start to replace the kinetic energy at B is half m times VB square, which is 2.5 square. Now, when you move from B to C, is the work of the weight positive or negative? You are moving downward. When you move downward, you have a positive work for the weight. Okay, so it's plus G times the displacement. Okay. If you want to apply the formula, if you consider y-axis upward, then you should put minus mg delta y, but delta y will be negative because you are moving down. Okay. So how to calculate delta y? Delta y is minus this distance. Okay. How to calculate this distance here from this point to this one? If I look geometrically at my figure, this distance d is the difference between the height h, which is 1 meter, okay, and this height here, which is 1 times cosine of theta. Okay, so if I replace, then I replace delta y by minus d, I get plus mg times d. Okay, so if I replace, it's plus m times 10, and I replace the distance by 1 minus cosine of theta, equals to, at the final state, it's half m times vc squared. So as you can see, the mass is present everywhere in all my terms. It will cancel out. And now I was able to write another equation having as variable theta and vc. So I end up with two equations with two unknowns. I can solve for my unknowns. Okay, and you will be able to calculate the velocity at c and the angle theta at which your block will leave the surface.
في طريقة تانية ولا لا؟
في طريقة تانية بس much more complex. This is much easier. إذا ما بدك تستعمل ال work and energy, you can write Newton law along UT, sum of t equals MAT. You will get, we can do it now if you want. You get the expression of AT, and you say that you use the relation between AT and the velocity to find the value of the velocity at this point. Then you replace the velocity back to get that. But it's much more complex. So work and energy is much easier. If you want, we can do it as you like.
لا لا ça va merci.
Okay, but it's feasible, but much more complex. And you can apply Newton law along UT. You get that AT. Let us do it in summary, just to know the idea. So if you project along UT, we said that the weight, the normal is along UN, no projection along UT. So only the weight will have a projection on UT. If you project on UT the weight, you get W sine theta. So when you write sum of forces along UT equals to MAT, okay, you will get that mg sine theta is equal to MAT. And m will be simplified. So you got your tangential acceleration AT is g sine theta. Okay, but we know that we have a relation between acceleration and velocity, which is AT ds, which is the displacement in the curvilinear position, equals to VdV. Now, if you replace AT by its value, which is g sine theta, you can see that AT is function of theta. And here the variable is s. So what you can do, you can relate s to theta. And here it's simple. Why? Because when you have a circular motion, you remember from school there is a relation between the angular displacement d theta and the linear displacement or the arc length ds. You remember what was the relation for a circle? ds is r times the radius of the circle times d theta. Because the length of an arc of circle is equal to the radius of the circle times the angle. So if you replace ds by r d theta, then the variable from the first side will be theta. And for the other side, the variable is velocity. But here you need to do integration. You should integrate the first side from theta at b, which is 0, to theta at c, which is unknown. So you will do integral from 0 to theta of the side. And for velocity, we'll integrate from velocity at b to velocity at c. This will give you the same relation we got by work and energy. And then you will be able again to solve two equations to unknowns. But here you need to do integration. For work and energy, it's more straightforward. Okay.
Okay,
Now,
merci.
welcome. Now, after we are done with the first step, they are asking, what is the distance x at which the block will hit the ground? Neglect friction and air resistance. What type of if you want chapter I should use here? After leaving
Trajectory.
exactly projectile motion, because after leaving the surface, the block will be only affected by the weight. So it's move under the weight effect. It's projectile motion. In projectile motion, all we need to know is the initial velocity, okay? And we can decompose it into x and y. And what they are asking for is what will be this distance from the center of the circle. So we need to determine the horizontal distance of displacement, okay? So what we can do here, we can just say that we need to determine, so for point C here, you can put the frame of your projectile motion at this location. So I can put, this is my x prime axis. This is my y prime axis. I know the velocity at c from the previous step, okay? I know its magnitude, but who can tell me, how can I determine its direction? How is the velocity at c?
Tangent to the arc.
Yes, very good. It's tangent to the circle, so it's perpendicular to the radius, okay? Since you calculated the angle theta here, you know this angle, okay? You have that the velocity at c, vc, is perpendicular to the radius, okay? And your x prime axis is perpendicular to the vertical line. So the angle between these two lines is equal to the angle between vc and x prime. So from the previous question, you